collapse risk assessment window evaluates a structure's seismic collapse performance against the acceptance criteria of FEMA P695, 2009, Chapter 7, Quantification of Building Seismic Performance Factors. It computes the adjusted collapse margin ratio from the fragility and pushover results already established in this series and compares that value against the methodology's acceptable thresholds. Specifically, this window implements Appendix F of that document, collapse evaluation of individual buildings. That distinction matters, and it changes several things from a literal reading of the general Chapter 7 methodology. Those differences are covered explicitly in this video. Open it from Analysis Type, Collapse Risk Assessment P695, found directly below Fragility Analysis. 3 prior analyses are normally expected before this window is used. Modal analysis for the fundamental period, T1 pushover analysis for the period-based ductility, and fragility analysis for the collapse level median intensity. Where any of these have not been run, the corresponding value can still be entered manually. Every field in this window remains editable, regardless of whether it was pulled automatically or typed in directly. SCT is extracted automatically from the most recently run fragility analysis, specifically its collapse fragility median. Where more than one fragility method has been run in the same project, FEMA pushover and SPO2IDA, for example, a drop-down allows a specific method's SAT to be selected rather than defaulting to whichever was run most recently. SMT, the maximum considered earthquake spectral acceleration, must be defined manually. This is a project and site-specific value the application cannot infer. It defaults to 1.5 purely as a placeholder. This must be replaced with the actual value for the site before the result means anything. The collapse margin ratio follows directly, SAT divided by SMT. Period-based ductility is pulled automatically from the most recently run pushover analysis or the analysis you selected. Where several pushover cases exist, different directions or different methods such as conventional, MPA, multidirectional, or adaptive, a drop-down allows period-based ductility to be loaded from any specific saved case. Multiple rows can be added to the ductility table, one per case. The governing period-based ductility is taken as the minimum across every case entered, the conservative choice and consistent with standard FEMA P695 practice. T1 is pulled automatically from modal analysis and can be edited manually if needed. The spectral shape factor is obtained by two-dimensional interpolation on T1 and the governing mu-T, using either Table 7 1A for seismic design category B, C, or D minimum, or Table 7 1B for D maximum. The applicable table should be selected to match the structure's own seismic design category. Total system collapse, uncertainty combines 4 sources by square root sum of squares per equation 7.5. Beta RTR, record-to-record uncertainty, is computed automatically from period-based ductility, fixed at 0.40 once period-based ductility reaches 3 or above. Otherwise, use the equation. The remaining 3 sources, beta DR for design requirements, beta TD for test data, and beta MDL for modeling quality, must be entered manually. These are judgment calls specific to the project, and the application cannot determine them independently. Tables 3.1, 3.2, and 5.3, shown on the right-hand side, serve as the grading rubrics. Each defines what qualifies as superior, good, fair, or poor for its respective source, with a corresponding numeric beta value of 0.1, 0.2, 0.35, or 0.5. As a numeric value is entered, the nearest matching quality grade cell is highlighted automatically across all 3 tables, so the qualitative rating behind each entry stays visible. One point specific to Appendix F is worth stating directly because an individual building's configuration is already fully known. Unlike a general archetype representing many possible designs, the Table 5.3's first row is the recommended choice for the representation of collapse characteristics axis of modeling quality and is marked accordingly in the reference table. Table 7 to 2A through D appears alongside these as a quick lookup cross-reference, valid only when period-based ductility is 3 or above. It is not part of the calculation path. Beta total is always computed directly from equation 7 to 5 using the numeric values entered. Beta total is used to interpolate the acceptable ACMR values from Table 7.3, shown and highlighted the same way as the SSF table. This is the point where Appendix F diverges most clearly from the general methodology. For an individual building, ACMR 10% is the primary acceptance criterion, not ACMR 20%. The ACMR 20% check exists in the general Chapter 7 methodology to identify outlier archetypes within a performance group made up of many buildings representing one system class. A single building has no group to be an outlier within, so that check is not the primary basis for pass or fail here. Both the results panel and the generated report lead with the ACMR 10% verdict, with ACMR 20% retained for reference only. Once every input is confirmed, Compute Collapse Risk Assessment runs the full chain: CMR, SSF, ACMR, beta-tot, and the acceptable ACMR comparison in sequence, highlighting the relevant reference table cells and displaying the primary verdict. The generated report covers every step in this chain, including the Appendix F disclosure explaining why ACMR 10% governs here, and states both pass-fail verdicts separately and clearly.